Good morning, dear students. My name is Ferhan Mazher, and today is 23rd of October 2021. The day is Saturday, and right now I am with the 9 Cambridge class. We also call it O1 class. And the subject we are studying is D Maths 4024. We are working on the syllabus. We are studying the new syllabus, Mathematics 7th edition, third book. And the chapter we are working is chapter number 3. The name of the chapter is Inequalities. And in this chapter today, we are working on the exercise 3C. This exercise is about the limits of accuracy. Here we will learn that whenever a certain measurement is given to you, and that measurement has always has some least count, and we call it this measurement is correct to a certain number. And by using that number, we will be able to tell the upper bound and the lower bound of that measurement. So we will practice these questions, and you will learn in this exercise that how to find the upper bound and lower bound of any measurement. So let's start. So the first question coming up on your screen. Here we go. So each of the following, that's question number 1. He says each of the following numbers is correct to 2 significant figures. So there are 6 parts of this question, and in each part you have to give us two things. You have to find 2 things. Give the upper and the lower bound for each of the following. That's the first question on each part. And the second question on each part is use X as the number. Express the range in which the number lies as an inequality. Okay. So for example, so each part in this question is correct to 2 significant figures. So in every part, we will see what does this mean. So for example, question number 1 coming on your screen is 4.6, and this is correct to 2 significant figures. So 4.6 is written here. So 4.6 has 2 significant figures. So first significant figure is 4. The second one is 6. So the value of this place in this number, you can see this is the first decimal place. So the value of this place is 0.1. So this number is correct to 0.1. So what you will do, and in all these questions we will do, this is correct to 0.1. And you will divide whatever correct, this is correct to, you will divide it with the 2, and with it we write plus minus. So when you divide 0.1 with 2, you get 0.05, and with this you always write plus minus. So the main reading is 4.6. So when you add this to the main reading, the main measurement, 4.6 plus 0.05, that give you 4.65. So that is the upper bound, the maximum value, the largest value. And the lower value, 4.6, the main measurement, minus this number. So 4.6 minus 0.05, that gives you 4.55. So that this is your lower bound, or the least value, or the minimum value. So 4.6 can be, its lower bound will be 4.55, its upper bound will be 4.65. So in the form of the inequality, I can write it like if X is that number, and so that number is greater than and equals to 4.55, the lower bound, and so 4.55, X is equals to and greater than 4.55 and is less than 4.65. So this is how you write that inequality. So that was the question number 1, and it's A part. Okay, so question number 1, B part, the number is 0.73. 0.73, and this is correct to 2 significant figures. So what are the significant figures here? 0 is not a significant figure. 7 is the first significant figure, and the 3 here, that's the second significant figure. So if you see what's the place value, the value of this place is, the value of this place is 0.01. So this number is correct to 0.01. So whatever it is correct to, you divide that with 2. So 0.01 divided by 2, you get 0.005. With it, you write plus minus. So in your main measurement, if you add this number, you will get the upper bound. from the main measurement, if you subtract this number, you will get the lower bond. So you can see the main measurement is 0.73. If I add 0.05, you get 0.735. If you subtract from 0.73, if you subtract 0.005, you get 0.725. So this is your upper bond and this is your lower bond. So in the form of the inequality, I can write x is greater than and equals to 0.725 and is less than 0.735. So this is how you write the inequality. This is your upper bond, this is your lower bond. So I hope you have understood this question. So we are moving to the next question. The next question is question number 1 and it's C part. The number given here is 680, and they say that it is correct to two significant figures. Okay, so now we will see that which numbers are significant. The first non-zero digit is significant. The second non-zero digit is also significant. So the two significant figure is here. The second significant figure is here. You can see I have marked it. So what's the place value? What is the value of this place? This is 10 basically. This is 10. So this is correct to 10. So whatever this is correct to, you divide that with 2 and you write with it plus minus sign. So 10 divided by 2, it will be 5 plus minus 5. So what you do, you take this number, you add it into your main measurement, you will get the upper bond. You subtract it from your main measurement, you get the lower bond. Your main measurement is 680. If you add in 685, in 680, if you add 5, you get 685. That's the upper bond. From 680, if you subtract 5, you get 675, and that will be your lower bond. So in the form of inequality, I will write x is greater than and equals to the lower bond and less than the upper bond. In other words, you say x is greater than or equals to 675 and less than 685. This is how you do question number 1, C part. Hopefully you have understood. The next part is question number 1. It's D part, and the number given to us is 1000. The number given to us is 1000. So here you can see this is 1000. So 1 is the first significant figure, and this 0 is the second significant figure. Now we will check that what's the place value of this location. This location is, you see, unit 10, 100. So this is 100 basically. The value of that location is 100. So divide, this is correct to 100. So divide 100 with the 2 and with it write plus minus. So when you divide 100 with 2, you get 50. With it, you will write plus minus. So in your main measurement, which is 1000, you add this number, you get the upper bond. From the main measurement, you subtract this number, you get your lower bond. So in 1000, you add 50, you get 1050. That is your upper bond. From 1000, if you subtract 50, you get 950. That is your lower bond. So in the form of the inequality, you will write x is greater than or equals to 9550 and less than 1050. So this is how you do question number 1. It's D part. Okay, so next part coming up on your screen is E part, and the number given here is 0.035. So these first two zeros, they are not significant. This is this 3 is your first significant figure, and this 5 is your second significant figure, because all the parts he said that they are correct to two significant figures. So I have marked this position. So what's the value of this location? The place value of this location, this location is, it is 0.001. So this number is basically correct to 0.001. So whatever it is correct to, you divide it that with 2 and you write it with it plus minus. So you will have, when you divide 0.001 with 2, you get 0.0005, and with this you write plus minus. So now what you do, the technique is very simple. You take your main measurement. If you add this number into main measurement, you get the upper bond. From the main measurement, if you subtract this number, you get the lower bond. So 0.035 plus 0.0005, you get 0.0355. So that's your upper bond. 0.035 minus 0.0005, you get 0.0345. So that is your lower bound. So now you can write, this is your upper bound, this is your lower bound. Now you can write x is greater than or equals to 0.0345 and less than 0.0355. So this is how you will do the question number 1. It's E part. So the next question is question number 1 and it's F part, and the number given to us is 72,000. So let's see, it's correct to two significant figures. 7 is the first significant figure and the 2 is the second significant figure. So this is your second significant figure. So what is the place value of this location? The place value here this is unit 10, 100,000. So this 2 is at 1,000 position. So this place is correct. So this number is correct to 1,000. So what you will do, you will divide 1,000 with the 2, and with it you write plus minus sign. So 1,000 divided by 2, that will be plus minus 500. So from in your main measurement, you add this number, you get the upper bound. In your main measurement, if you subtract this number, you get your lower bound. So 72,000 plus 500, that will be 72,500. From 72, that is your upper bound. From 72,000, if you subtract 500, you get 71,500, and that is your lower bound. So you can write this in the form of inequality, and that will be written like this: x is greater than or equals to 71,500 and less than 72,500. So my dear students, this was question number 1, a very simple question in which you have to find out the upper bound and the lower bound. But there was a problem that he said that each number is correct to two significant figures. So when in each number separately, you check which one is the second significant figure. So we have to take the place value of that digit, and that is a big problem to recognize. What's the place value of that digit? The rest of the thing is very simple. Okay, so now we are going to the next question, and the next question coming up on your screen is question number 2. And let me read it from the book. It's a story sum. Listen carefully to the question. The capacity of a tank given as 0.6 meter cube has been rounded off to the nearest centimeter cube. Calculate the upper and the lower bound range of its capacity. Remember this question, and there is a misprint in the book. This number is not actually 0.6 meter cube. This number is actually 0.62 meter cube. So this number is not 0.6 meter cube. Actually, it is 0.62 meter cube. There is a misprint in the question in the book. Okay. So first of all, I have done this whole question with supposing that 0.6 meter cube is the correct statement or the number given in the question, and then I will show you what if the reading is 0.62 meter cube. So the capacity, let's do first of all with this number, and then we will do with the actual number. So this is the misprint which was in the book. They said that the capacity is 0.6 meter cube. So and it is correct to nearest 1 centimeter cube. One thing is very important. The main measurement is in meter cube, but correct to nearest 1 centimeter cube. So both the units are not consistent with each other. The units are different from each other. One is meter cube, the other one is centimeter cube. So you see, whatever this is correct to, you divide that with the 2. So this is correct to nearest 1 centimeter cube. So I will divide it with the 2. So I get plus minus 0.5 centimeter cube. The capacity of the tank is, if it is 0.6 meter cube, I will convert it into centimeter cube. If you want to convert meter cube into centimeter cube, you have to multiply with 10 raised to power 6, or rather 1 and 6 zeros after 1. So I will have to multiply it with the 1,000 actually, you can say like this. It's 10 raised power 6. You see, when I multiply 0.6 with 10 raised power 6, so my answer comes out to be 600,000 centimeter cube. So the capacity of that tank is 600 centimeter cube. So you see what I have done. I have converted the main measurement. I have converted its units from meter cube to centimeter cube. Now, that was correct to 1 centimeter cube. So when I divided 1 centimeter cube with the 2, I got 0.5 centimeter cube. So in your main measurement, you will add this number. You will get the upper bound. If from the main measurement, you will subtract this number, you will get your lower bound. So here you can see I have written this. The main measurement is 600,000 centimeter cube. And when I added 0.5 in it, so I got 600,000.5 centimeter cube. And when I subtracted 0.5, so I get 599,999.5 centimeter cube. So this is, if you suppose that the question which is given in your exercise, the capacity is 0.6, which I'm telling you is a misprint, then this will be the answer. But when you look at the answers which are given at the end of the book, then you will realize that this number, the main capacity, was not 0.6 meter cube. Actually, it was 0.62 meter cube. So here I have done it again, so I can show you that the exact question is, it was supposed to be, the capacity of the tank was supposed to be 0.62 meter cube. So I have solved it with this number also. So if the capacity is 0.62 meter cube, then I will convert it into the centimeter cube. For this purpose, I will multiply it with 1,000, and I will get 620,000 centimeter cube. So in this measurement, I will add 0.5. So I will get the upper bound. From this measurement, if I subtract 0.5, I will get the lower bound. So when I added in 620,000 centimeter cube, I added 0.5 centimeter cube, I get 620,000.5 centimeter cube. And when I subtracted it, then I get 619,999.5 centimeter cube. So this is how you do this question. The problem with this question was that in the book, they say the capacity is 0.6 meter cube, but that's a misprint. The actual capacity of the tank is 0.62 meter cube. A little tricky question, and due to the misprint, the question has become even more confusing. So I hope you have understood the problem and the misprint and the rest of the thing. Okay, so the question number 3 is coming up on your screen. Let me read that question from the book. He says, the duration of a flash from a camera is timed at 0.004 seconds, accurate to 1/1000 of a second. Calculate the upper and lower bounds for the duration of the flash using inequalities. Okay. So you see the time is, the main measurement is time. Time is in 0.004 second. And they say this is correct to 1/1000 of a second. 1/1000 of a second in decimals will be 0.001 second. So when you divide 0.001 second with the 2, you get 0.0005 seconds. With it, you write plus minus. In your main measurement, which is 0.004 second, if you add 0.0005, you get 0.0045 seconds. That's your upper bound. And from the main measurement, which means 0.004 seconds, if you subtract 0.0005, you get 0.0035 seconds. So that's your lower bound. So now we have the upper bound and the lower bound. So I can write it in the form of the inequality that the time is equals to and greater than 0.0035 seconds and less than 0.0045 seconds. So this is how you will do the question number 3. Hopefully you have understood this. Now, we are going to start question number 4, and the question 4 has A, B, C, D, and E part. And the statement of the question is, give the upper and the lower bounds for each of the following. The A part is 750 liter to the nearest 50 liter. So here with the main measurement is 750 liter, and this is correct to nearest 50 liter. So whatever it is correct to, which is 50 liter, you divide that number with 2, and with it you write plus minus. So 50 liter divided by 2, that will give you 20 plus minus 25 liter. So in your main measurement, if you will add this, you will get the upper bound from the main measure. If you will subtract this, you will get the lower bound. So 750 plus 25, that will be 775 liter, and that is your upper bound. 750, which is your main measurement, and from it, if you subtract 25 liter, you get 725 liter. That is your lower bound. So you see, this is very simple. This is how you find the upper bound and lower bound. That is question number 4A part. And question number 4B part, he said 30 second to the nearest 10 second. 30 seconds. So the main measurement is the 30 second, and this is correct to 10 second. So what you will do, you will take 10 second, you divide it with the 2, whatever the answer comes, with it you write plus minus sign. So 10 second divided by 2, it will be plus minus 5 seconds. In your main measurement, if you will add the 5 seconds, you will get the upper bound of the time. And from the main measurement, if you subtract the 5 seconds, you will get the lower bound of that measurement. So 30 second plus 5, that will be 35 seconds. You get your upper bound. And from 30 seconds, which is the main measurement, minus 5 seconds, and that will give you your lower bound 25 seconds. So very easy. That's the question number 4A and B part. Hopefully you understand. It's very, very simple. Question number 4 and its C part, he says 758 kg to the nearest kg. To the nearest kg means 1 kg. So 758 kg is the main measurement, and this is correct to 1 kg. So what I will do, that's the standard procedure, 1 kg divided by 2, and that will be 0.5 kg. With it, I will write plus minus sign. I will add this to the main measurement, and you will get the upper bound from the main measurement. If I will subtract this number, you will get the lower bound. So 758 plus 0.5, that will give you 758.5 kg. That is the upper bound. From the 758 kg, if you subtract 0.5 kg, you get 757.5 kg. That is the lower bound of this measurement. Hopefully you understand. This is question number 4 and it's C part. Question number 4 and its D part is 1500 gram to the nearest gram. Okay. Now the main measurement is 1500 gram, and this is correct to nearest gram. Nearest gram means 1 gram. So you will divide 1 gram with the 2, you get 0.5 gram. With it, you write plus minus sign. So in the main measurement, which is 1500 gram, if you will add 0.5 gram, you will get the upper bound of the measurement. From the main measurement, that is 1500 gram, if you subtract 0.5 gram, you will get the lower bound of the mass. So the mass is 1500 gram. We added 0.5. You got 1500.5 gram. That's the upper bound. From 1500 gram, if I subtract 0.5 gram, I get 1499.5 gram. And that is the lower bound of this measurement. The next question coming up on your screen, you can see is question number 4 and it's E part. He says 495 centimeter to the nearest 5 centimeter. So the main measurement is 495 centimeter, and this is correct to 5 centimeter. So I will divide 5 centimeter with the 2. So whatever the answer comes with it, I will write plus minus. So plus minus 2.5 centimeter. So in the main measurement, if you will add this number, you will get the upper bound. From the main measurement, if you will subtract this number, you will get the lower bound. So 495 plus 2.5, that gives you 497.5 centimeter. From 4, that's the upper bound. So 495 centimeter, which is the main measurement. In it, if you will subtract 2.5 centimeter, you will get 492.5 centimeter, which is the lower bound. So very easily you can see that if you have the main measurement and if you know that it's correct to what number, very easily you can find the upper bound and the lower bound of the main measurement. So we are done with the question number 4. So let's move to the next question. Question number 5 is coming up on your screen. A diagram is given here. It's a triangle, and its 3 sides are given. The side number 1 is 8 meter, the side number 2 is 6 meter, and the side number 3 is 10 meter. He says the measurements given are to the nearest meter. It means that all these lengths, they are correct to 1 meter. So 1 meter divided by 2, that will give 0.5 meter. With it, you will write plus minus sign. Then their question is, calculate the upper and lower bonds for the perimeter of the above triangle. So we have to find out the perimeter of this triangle. You know, the perimeter of the triangle is the sum of the 3 sides. That's a simple formula for the perimeter. But we have to tell the upper bond and the lower bond of this perimeter. The procedure is, we know the 3 lengths. We will find the upper and the lower bond for each length, and then we will go to the perimeter. So for example, length number 1, that is 8 meter long. So its upper bond will be 8 plus 0.5, that will be 8.5 meter. Its lower bond will be 8 minus 0.5, that will be 7.5 meter. In the same way, length number 2 is 6 meter. In it, I will add 0.5. I get 6.5 meter. That's the upper bond of the length number 2. And from 6 meter, if you subtract 0.5 meter, and that will be 5.5 meter, that will be the lower bond of this length. In the same way, the length number 3 is 10 meter. And if you add 0.5 in 10, you get 10.5 meter. That's the upper bond of this length. And from the 10 meter, if you subtract 9.5 meter, if from 10, if you subtract 0.5 meter, you get 9.5 meter. That's the lower bond of this length. Now, the first question is, find the upper bond of the perimeter. You know, the upper bond of the perimeter, that is the perimeter is basically equals to length 1 plus length 2 plus length 3. If you want the upper bond of the perimeter, you have to use the upper bound of the length 1, upper bound of the length 2, upper bound of the length 3. So you can see I have used the upper bond, L1 8.5, L2 6.5, and L3 10.5. So you get 25.5 meters. So that's the upper bond of the perimeter, and that's how you do it. The second part of this question is, he says, find the lower bound of the perimeter. If you want to find the lower bound of the perimeter, the formula is same, length 1 plus length 2 plus length 3. But because you want the lower bound of the perimeter, so we will use the lower bound of the length 1, we will use the lower bound of the length 2, we will use the lower bound of the length 3. So you can see we have put the lower bonds of each side. L1 is 7.5, L2 is 5.5, and L3 is 9.5. You add them and the answer is 22.5. So the upper bound of the perimeter will be 25.5 meter and the lower bound of the perimeter will be 22.5 meter. I hope that you have understood that how this question is done. So we are going to the next question. The next question is question number 6, and I'm going to read from the book. It says, of 600 students in a school, 297 are boys. Calculate the maximum number of girls. Number of students is rounded off to the nearest 100. So here in this question, you see the total number of students are 600, and this number is correct to nearest 100. The boys are exactly 297. Their question is, how many maximum girls are there? You see, the total students, which was 600, he said, and that number was correct to 100. So divide 100 with the 2, you get 50. With it, you write plus minus. So the total student is 600. In 600, if you add 50, you get 650, and that is the upper bound of the total number of students. And in 600, from 600, if you subtract 50, you get 550. So that's the lower bound of the total number of students. The girls will be equals to total students minus boys. Now you want the maximum number of girls. The formula is girls will be equals to total students minus the boys. So if you want the maximum girls, the upper bound of the girls, or you want the maximum number of girls, logically, the total should be taken. You should take the upper bound of the total, and the boys, there's no upper or lower bound for the boy. So for the total, you should also take maximum possibility. So the maximum girls will be equals to the total's maximum will be 650 minus 297. That will be 353. So there are 353 girls, maximum girls possible. So that was question number 6. Now we are going to do question number 7. Listen carefully to the story. He says a length of 25 centimeter is cut from a string that measures 50 centimeter. Given that the measurements are corrected to 1 decimal place, express the upper and lower bounds of the length L centimeter of the string left in the form of an inequality. Okay, so suppose the total length is 50 centimeter. I'm representing it with the capital L. That total length is 50 centimeter, and they have told us that this is correct to 1 decimal place, so that this is correct to 0.1 centimeter. When you divide 0.1 centimeter with the 2, you get 0.05 centimeter. So your main measurement is 50 centimeter. When you add 0.05 in it, you get 50.05 centimeter. From 50 centimeter, if you subtract 0.05 centimeter, you get 49.95 centimeters. So that is your lower bound. 50.05 centimeter is your upper bound for the total length. So now from the total length, they cut a piece of 25 centimeter. And this is also correct to 1 centimeter. Sorry, it's also correct to 1 decimal place. So 1 decimal place means 0.1 centimeter. So divide 0.1 centimeter with the 2, you get 0.05 centimeter. You add it, you subtract it into your measurement. So the main length is, which is cut, that's 25 centimeter. In it, with I will add 0.05 centimeter, you get 25.05 centimeter. That's the upper bound of the length which is to be cut. And from 25, if you subtract 0.05 centimeter, you get 24.95 centimeter, which is the lower bound of the string which is to be cut. Now he wants he has given us 2 questions. He says the remaining portion, I'm representing it with the L prime. He wants the remaining portion maximum. The remaining portion will be from the total L minus this small l. So if we want the maximum answer, so this first number should be maximum. That's the logic. First number should be maximum, and this number and that's length to be cut, that should be minimum. Then from this subtraction, you get the maximum answer. So L maximum, capital L maximum will be 50.05 minus, and the lower value of the length to be cut is 24.95. So when you subtract them, you get 25.1 centimeter. That is the maximum length left. Now, if you want to find out the minimum length which will be left, so minimum length left will be the original length minus the length to be cut. And because you want the minimum answer, the capital L value should be taken minimum, and the small l value should be taken as maximum. So then you will get the minimum answer out of this. The lower bound of the capital L is 49.95, and the upper bound of the length to be cut is 25.05. So when you subtract 49.95 minus 25.05, you get 24.9 centimeter. So now the length remaining, its upper bound will be 25.1 centimeter. Sorry, its upper bound will be 25.1 centimeter, and its lower bound is 24.9 centimeter. So this can be written in the form of an inequality. You can see here I have written it. The L prime, or the length left, will be equals to and greater than 24.9 centimeter, and it will be less than 25.1 centimeter. This question is little tricky, but I have tried my best to explain it to you that how this is done. So that's question number 7 from the exercise 3C. We are working on the limits of accuracy. I hope you understand this. Next question. Okay. The next question coming up on your screen is question number 8. He says, listen carefully to the story. He says, the radius of the trunk of a tree is measured to the nearest millimeter. If its radius is 20 centimeter, find its minimum circumference in centimeters. So its minimum circumference you have to tell in centimeters. Now you see the radius is 20 centimeter. I can convert this into millimeters. If you want to convert centimeter into millimeter, you multiply them with 10, because in 1 centimeter there are 10 millimeters. So 20 centimeter will be equals to 20 multiplied 10, and that will be 200 millimeter. 20 centimeter will be equals to 200 millimeter. And that reading is correct to nearest 2 millimeter. So I will divide 2 millimeter with the 2 and I get 1 millimeter. So with it, I will write plus minus sign. In our main measurement, which is 200 millimeter, I will add this number. You get 201 millimeter. And from 200, if you subtract 1 millimeter, you get 199 millimeter. So the circumference, actually, we want to find the circumference. The formula for the circumference is 2 pi r. So you want the minimum value of the circumference. If you want the minimum value of the circumference, the radius minimum value should be entered. So the lower bound of the radius should be entered here, because we want the minimum value of the circumference. So C is equals to 2 pi r. C is equals to 2 multiply pi multiply the lower bond of the radius is 199. So I will put that value. So in your calculator, if you will multiply 2 with pi with 199, you get 1250.35 millimeter. But they want you to answer in centimeters, so divide this with 10. So you will get 125.04 centimeters. So this is approximately 125.0 centimeters. So this is how you find the circumference, the minimum circumference of that trunk, the tree trunk. So that was question number 8. Hopefully you have understood. So let's move to the next question. The next question is coming up on your screen. That's question number 9. And listen carefully to this story. He says, a car traveling at a speed of 60 kilometers per hour to the nearest 10 kilometers per hour covers the distance in 3 hours to the nearest hour. Calculate its range of distance in the form of an inequality. Okay. So the speed of the car is given, that is 60 kilometers per hour, and this speed is correct to 10 kilometers per hour. So whatever it is correct to, you divide that number with 2, you get 10 divided by 2, that gives you 5 kilometers per hour. With it, you write plus minus. So the main measurement of the speed is 60 kilometers per hour. In it, you add 5, you get 65 kilometers per hour. That's the upper bound of this speed. From the main measurement, I mean 60 kilometers per hour, you subtract 5 kilometers per hour, you get the lower bound of the speed. So you get 55 kilometers per hour. So now I know the upper bound and lower bound of the speed. Then he says the time taken is 3 hours, and this is correct to 1 hour. So 1 hour divided by 2, that will give you 0.5 hours. So with it, I will write plus minus. Your time is 3 hours. If you add 0.5 in it, you get 3.5 hours. That's the upper bound of the time. And from 3 hours, you subtract 0.5 hours, and that will give you the lower bound, that will be 2.5 hours. So now I know the upper and lower bound of the speed, and I know the upper and the lower bound of the time. Their question is basically, you have to find out the distance traveled, the maximum distance traveled, and the minimum distance traveled. It means you have to find the upper bound and the lower bound of the distance traveled. So the distance is equals to speed multiplied time. If you want the maximum distance, the maximum speed should be used and the maximum time should be used. So the maximum speed is 65, the upper bound of the speed is 65, and the upper bound of the time is 3.5. So 65 multiplied 3.5, that will be 227.5 kilometers. So that's the maximum distance it can travel. The minimum distance traveled, the formula for the distance is speed multiplied time. You can see here, speed multiplied time, because you want the minimum value of the distance traveled, that will be speed multiplied time. You will use the lower bound of the speed, and we will use the lower bound of the time. The lower bound of the speed is 55 kilometers per hour and the lower bound of the time is 2.5 hours. So multiply 55 kilometers per hour with 2.5 hours, you get 137.5 kilometers. So now you see, we know the upper bound of the distance traveled, that's 227.5 kilometers, and we know the lower bound of the distance traveled, that is 137.5 kilometers. So I can write this in the form of an inequality. So the distance traveled will be greater than and equals to 137.5 kilometers and less than 227.5 kilometers. So that is question number 9, my dear students. This topic is very, very, very important. So now we are moving to the next question. The next question coming up on your screen is question number 10, and listen carefully to the story of this question. He says, the density of a given material is 2.4 gram per centimeter cube. If its mass to the nearest 10 gram is 30 gram, find its minimum and maximum volume, giving your answer correct to 3 significant figures. Okay, now you see, he says that the density is 2.4 grams per centimeter cube and the mass is 30 grams, and that is correct to 10 gram. So I will divide the 10 gram with 2, you get plus minus 5 gram. So in your main measurement of the mass, if you add 5 gram, you will get the upper bound. From the main measurement of your mass, if you subtract this number, you will get the lower bound. So 30 gram is our main measurement, and in it, if I will add 5 gram, so I get 35 gram, that's the upper bound from 30 gram, which is the main measurement. If you subtract 5 gram, you get the lower bond, that's 25 grams. So the mass upper bond will be 35 gram and the mass lower bond will be 25 gram. You know, the volume is equals to mass divided by density. Volume is equals to mass divided by density. You want the maximum value of the volume. If you want the maximum value of the volume, the mass maximum value should be used, because this is division. So the numerator should be maximum. So the V can be the upper bound of the mass is 35 divided by 2.4. That will give you 14.58 gram, and to the 3 significant figures, it will be 14.6 gram. So if you want the minimum value, the formula of the volume, the formula for the volume is mass divided by density. So if you want the minimum value of the volume, the mass should be minimum. So I will write the lower bound of the mass, that's 25. The density is still 2.4. So when you divide 25 with 2.4, you get 10.42 gram. So the correct answer in the 3 significant figure will be 10.4 gram. So the maximum value of the volume will be 14.6 gram and the minimum value of the volume will be 10.4 gram. So my dear student, that was question number 10. Hopefully you have understood. So let's move to the next question. The next question coming up on your screen is showing up on your screen. That's question number 11. And let me read the question, the story of the question from the book. It says, if 1 liter of paint costs 1 liter of paint coats an area of 3 meters square to the nearest meter square, find the maximum amount of paint is required to coat a wall of area 700 meters square to the nearest meter square. So here we have, if you have 1 liter of the paint, it can paint 3 meters square area. And this area is correct to 1 meter square. So divide 1 meter square with 2, you get 0.5 meters square. So this area 1, which is 3 meters square, its upper bound will be 3 plus 0.5, that will be 3.5 meters square. And from 3 meters square, if I will subtract this number, I will get 2.5 meters square. That's the lower bound of the area 1. The area 2, which is to be painted, that is 700 meters square. And that is also correct to 1 meter square. So divide 1 meter square with 2, you get 0.5 meters square. So 700 meters square plus 0.5, that will be the upper bound. So that will be 700.5 meters square. And for lower bound, from the main measurement, you subtract this number 700 meters square minus 0.5 meters square. So you get 699.5 meters square. So the upper bound of the area 2 is 700.5. Its lower bound is 699.5 meters square. Now the volume required of the paint, that will be equals to volume 1 divided by area 1. Volume 1 divided by area 1 is basically liters per meter square, means the petrol required to paint 1 meter square. V1 divided by A1 multiply A2. So this is how you find the volume of the paint required to paint the area 2. V1 divided by area 1 multiply area 2. So because you want the volume required, you want the maximum volume. So for that purpose, because the A2 is in the numerator on the other side, that should be maximum, and A1, which is in the denominator, that should be minimum. Then you will get the maximum answer out of this formula. So the A2 should be taken as maximum, A1 should be taken as minimum. A2 is in the numerator, so that's why it should be taken maximum. A1 is in the denominator, so that's why it should be taken as minimum, because out of this formula, we want the maximum value. We want the maximum value of the volume. So V1 is 1 liter, and the area 1 is lower value is 2.5 meters square. And A2, I have to put maximum value here, and that will be 700.5, 700.5 meters square. So you just multiply this on the calculator, you get 280.2 liter. 280.2 liter. This question goes little tricky. Read this question from the book and try to understand. I hope I have tried myself best that I can explain it to you. So anyway, we are going to the next question. The next question is question number 12. So question number 12 is showing up on your screen, and let me read it from the book. He says, a cylindrical water tank has a capacity of 50 liter when measured to the nearest 10 liter. A bottle has a capacity of 1 liter when measured to the nearest liter. Calculate the maximum number of bottles of water that can be drawn from the tank, sorry. So here we have a water tank which is 50, it has 50 liter capacity, and he says this is correct to 10 liters. So I will divide that 10 liter with the 2, you get a 5 liter. With it, I will write plus minus sign. So my main measurement of the volume of the water tank is 50 liter. And when I will add this number, I will get the upper bound. I will get 50 plus 5, that's 55 liter. That's the upper bound of the water tank's capacity. And from this main measurement, if I will subtract this, you get the lower bound. So 50 minus 5, that will be 45 liter. That's the lower bound of the volume of the water tank. Now they are talking about bottles. He says each bottle is 1 liter, and that is correct to 1 liter. So I will divide 1 liter with the 2. I will get plus minus 0.5 liter. So your main measurement is the volume of the bottle, that is 1 liter. I will add in it 0.5 liter. So I will get the upper bound of the volume of one bottle. I get 1.5 liter. From 1 liter, I will subtract 0.5 liter. That's the, so you get 1 minus 0.5, you get 0.5 liter. So the upper bound of the volume of that bottle is 1.5 liter, and the lower bound of the volume of the bottle is 0.5 liter. Now he wants the number of bottles, and he wants the maximum number of bottles possible. The number of bottles, the formula will be the volume of the water tank divided by the number of the bottles. So it's a division. In this formula, we have division. Water tank's volume divided by the bottle volume. Now, because you want the maximum answer from this division, so the numerator must be maximum and the denominator must be minimum. So the water tank, the volume of the water tank should be taken maximum. We have to take its upper bound. and the bottle of the volume, which is in the denominator, that should be minimum, or you should use its lower bound. So the water tank volume, I will use its upper bound, that's 55 liter, and the lower bound of the volume of the bottle, that's 0.5 liter. So 55 liter divided by 0.5 liter, that will give you 110. So from this tank, the maximum number of bottles which can be filled will be 110 bottles, and that will be only possible if you have taken the upper bound of the volume of the water tank, and you have taken the lower bound of the volume of the bottle. But the final answer is 110. And by this question, we have reached the end of this exercise. So I hope that you will be able to do more questions on it, and on the limit of accuracy. You see this upper bound, lower bound, maximum, minimum thing, that's frequently come in Cambridge exam. So this exercise is in this chapter 3 of the D3. The name of the chapter is Inequality, and the name of the topic for this exercise 3C is limit of accuracy. The name of the chapter is Inequality, but this exercise is there. So I will try to make another video, and that video will be about the review exercise of the chapter number 3. And there are some questions of the lower bound and the upper bound and limit of accuracy in the review exercise 3. When I will make that video and upload it, you can practice from there. Remember one thing, by watching just the videos, you will get the concept, but you cannot master the concept. If you want to master the concept of mathematics, any particular concept, it is very important that you solve that exercise independently. Once you have understood the concept, then try to solve that exercise independently. This is very important. These videos which we are making will only help you when you get stuck, or if you want to have a look at that exercise very quickly, you can watch these videos. But actually you will become master of the limit of accuracy when you will practice this exercise independently on your own. Remember my words. So thank you very much, everybody. It was a great pleasure teaching you all. If you find this video useful to you, if you find that this video has helped you to understand the limit of accuracy, the upper bound, the lower bound, and how this is used in formulas, subscribe to my YouTube channel, like my video. And if you think this is helpful to you, and this video can be also helpful to your friends, don't hesitate to share the link of this video on your Facebook and on your Twitter accounts, because that will be a great appreciation for this work, and that will provide energy to me, and I will continue doing this work. Thank you very much, everybody, once again, and have a good day, and God bless you all.